Hi all, welcome to video 5 of the langchain playlist. So in previous video we have started with the introduction to components of langchain. In the previous video we have shortly got introduced to the models component of the langchain. Okay, and we have seen a short, I think, the simple examples about the models, right? How models are able to bring consistency in interfaces, right? Using which we can interact with AI models. So we can interact with any AI model with very small amount of code, right? And then I think there are few more components that we have to take an introduction to. Please remember, this is just an introduction to all these components, just a quick idea what all these components are. Going ahead, all these components will be taught in details, okay? The coding and everything, okay, related to these components, we are going to discuss in details, right? So let's understand about the remaining components like prompts, chains, memory, indexes, and agents, right? So what we'll do, we'll start with prompts, right? We'll start with prompts. Okay, now what are prompts? So prompts are the second component of langchain. It is the input that we send to LLM. Okay, so input we send to LLM are called as input or inputs, right? Is called as prompt, right? Prompt, right? So I think in last video, right? Just a second. Yes, we sent some input to the LLM. For example, this one, right? What is the capital of France? So this is the query or question or the input that we sent to the LLM, and from LLM we got Paris as output. So the input, whatever input we are sending to LLM, it is called as prompt, right? And please remember, the output of LLM is mostly dependent on the prompt, the way we are writing the prompt, right? There are many things in LLM like hallucinations and all these things. Hallucination mean if LLM is not aware of the answer, still it will not give you a negative response. It will try to give you some answer, right? So there are many ways to avoid hallucination in LLM. We can use that, or we can integrate that in prompt. Okay, there are multiple prompts available. We will learn all of those in details. Okay, as of now, just remember, the prompts is inputs that we send to LLM. Okay, and there is no new field that is getting emerged, which is called as prompt engineering, right? So it is a separate field that is getting emerged, so that now you understand the importance of uh, writing the prompt or engineering the prompt. It has a separate branch, right? That has got evolved. So prompt has got huge importance in terms of GenAI or LLM engineering, right? Fine. The next component is chains, right? Chains in LLMs. Okay, so I think we have already got some introduction in previous videos. Chains are like, using chains we can build pipelines. Okay, we are able to, I would say, connect the components using chain. Okay, we can give the pipeline shape to our LLM application using chains. Okay, for example, let's say, let's take a small example. Let's say we have some data in 1,000 words, right? Which is in some language different from English, right? Let's say it is in Spanish, right? And we want to generate summary of that 1,000 words data in English. Okay, and we want that summary in 100 word summary, right? Now the input, right? The input to the first step would be the 1,000 words, 1,000 words Spanish text, for example, right? Now the next step would be this 1,000 words Spanish text to be translated to English, right? So translate the 1,000 words Spanish text to English, right? So what we'll do here, basically, we'll send it to some LLM. Okay, we will sending to LLM and getting translated text, right? This is one of the steps. Now the next step is send the 1,000 words English text, right? English text that we have received in step 2 to LLM and get 100 words summary, right? Okay, so these are the steps, high level steps available. For example, the thing that we saw, the example that we saw in last video, right? It was the only one step. We were sending, let's say, some question to LLM and we were getting some output, right? But generally, when we are working on LLM applications, right, it involves thousands of steps. Sorry, not thousands of steps, multiple steps, right? 5, 10, 15, 20. There are n number of steps that are involved. Okay, now to connect all these steps, okay, if we do not use the chains in the lang chain, we will need to design this pipeline. Okay, we'll have to code to connect these components manually, right? Chains solve this problem. Okay, chains, what chains do? Chains automatically make the output of previous stage as input of next stage. Okay, what I mean to say, let's say this input I'm giving, okay, this is my first step. Okay, I'm giving this input to LLM, let's say input to LLM, right? Now from this LLM I'm getting, let's say, 1,000 words English text, right? Now this 1,000 word English text, it is input to LLM, right? And this chain will do automatically, right? Input to LLM for summary, let's say, right? Input to LLM for summary. Okay, and I'll get the output from LLM. Output from LLM, right? Which would be summary, right? So what chain will do? Chain will make the output of previous stage as input of next stage automatically, right? So we don't need to write the code for that. Okay, and there are multiple types of chains available: simple chains, parallel chains, right? We will be learning all these types of chains in details. Okay, fine. The next component is indexes. Okay, now indexes basically connect our application to external knowledge base, right? That can be PDF, that can be website, that can be any database, right? So I think the one example that we saw in the previous video was, this is my external knowledge base. This is my, let's say, PySpark series nodes. And from these nodes, I want to understand something about when otherwise in PySpark, right? So indexes are used for such use cases. Okay, I'll just write here indexes connect our application, right? LLM application to external knowledge base, right? So now there are four um, parts, we can say, or four things available inside indexes. The first is document loaders. Document loaders, right? I'll just first write all the four parts, right? And then we will discuss them. Okay, document loader, text splitter, vector stores, right? And fourth one is retrievers, right? Now what are document loaders? Document loaders is like, let's say, the same example we will take, right? uh, this PySpark nodes I have, and I want to load these nodes, okay, to send it to LLM, right? I need to load it from somewhere. Okay, so for that we have document loaders to load the documents in my application, right? Text splitters is like splitting the text based on, let's say, I want to split the text based on paragraph. I want to split the text based on, let's say, for each video, for example, I want to split wherever I have the keyword session, right? The text to be split so that I have different chunks for each of my session, right? So for that purpose we use splitters. Vector stores are the stores where uh, when we prepare embeddings of these chunks, okay, and embeddings, let's say I have 62 sessions in my PySpark series, so I'll be having 62 embeddings to store. Why we prepare embeddings? We prepare embeddings to do a semantic search, right? So vector stores are types of databases where we can store embeddings, okay, and retrievers is like retrieving the relevant chunks from the vector store, okay. So these are mostly used in case of RAG application, okay. Now the RAG application, why we need to connect our application or LLM with the external knowledge base? This is because let's say if we are using chat gpt, right, chat gpt can answer almost all the questions which are not related to some private data, okay. If you are asking about some, let's say, policy of your organization, right, so that chat gpt could not answer because chat gpt, this data is not made public, right, this data is confidential to employees, right. Now if you want to create some application, right, around this, let's say you have a rule book of your organization or policy book of your organization, right, and you want to prepare a question answering system, right. Let's say I want to ask about what is the sick leave policy of my organization, right. So it will give me, let's say, the policy number or policy link for that output, and it will summarize what is the sick leave policy, right. Now basically to implement such systems, right, we load the rule book or we load the policy documents, right, using document loader, okay. Now let's say I have 1,000 policies of my organization, right. So what we will do, we will split the each policy, okay. So I'll be having 1,000 chunks of my document, right. Then what I'll do, I'll send it to some embedding model, okay, all 1,000 chunks, and we will generate the embeddings or vectors of those 1,000 chunks, right. So I'll be having 1,000 embeddings, okay. Now to store those vectors, we will use vector store, right. And as soon as we get user query, we will embed that query also, and retriever will um, just retrieve only relevant documents or relevant chunks for this from this vector stores, right. So this is how indexes come into picture when you want to connect the application to some external knowledge base, right. I hope you have got high level understanding of indexes, okay. Now the next component of langchain is memory, okay. Now what is the relevance of memory? Basically, the LLM API calls are stateless. Okay, always remember LLM API calls are stateless. Okay, if you what I mean by this is, let's say I'm asking the first question to LLM, who is the best finisher in Indian cricket, right? So I'll get some answer. Let's say I'm getting answer as MS Dhoni, right? Now, if I ask second question to LLM, which IPL team he is part of, right? So LLM has no idea who is he, right? So LLM does not store the memory of previous operation. Okay, LLM APIs. Okay, whatever LLM APIs, right? So we all know the big companies have stored the APIs on their servers, and we are hitting them, right? So if I hit the API for first question, who is the best finisher in Indian cricket, I'll get an answer. If I send them the second question, okay, which IPL team he is part of, my LLM is not aware. Okay, LLM is not aware about who is he. I'll give you a small example, right? For example, let me run this. Okay, the first question, okay, who is best finisher? Who is, let's say, known as best finisher, right, of Indian cricket team, right? Let me send this question to LLM. Okay, though we are using langchain here, we are not using the memory component here. Okay, So let's maybe wait for this to run. Whatever this installation and all that stuff, I'm going to explain you in upcoming videos, so don't worry on that part. I'm just giving you a small demo, right? Like first hit we are sending to LLM API, and our question is, who is known as the best finisher of Indian cricket team, right? I think it is running. Okay, let it run. Okay. Okay, yeah, this also started running. Let's wait for the answer. But this is the memory, right? Whatever API calls we are sending to LLM, they are stateless, means they don't send. Okay, I would say uh, they don't store the memory. Okay, it has answered based on his right abilities. Mahendra Singh Dhoni has given the answer. Now, if I ask them which IPL team he is part of, which IPL team he is part of. Now what is this? I have sent the first API, first question to LLM, right? Now again I'm sending second question to LLM, right? Now if I these two are different questions. These two are same for me, right? I know about whom I am talking about, right? But LLM will tell me, please provide the name of person you are referring to. I need to know who is he, right? So from this, we have got to know that LLM API calls are stateless, right? And there is memory component of langchain which will keep the history, so that it will send the history to LLM, and LLM API calls. I mean, we can though LLM API calls are stateless, we can still okay, we can still get the answer. This is very important. I think memory part is very important when we are working on chatbots. Okay, for example, you have some chatbot, let's say you are asking about what is the price of product with product ID 1, right? And you have got the answer. The price of product with product ID 1 is, let's say, 1000 rupees, right? Now second question, if you ask to that chatbot that what are the features of this product, if the memory component is not there, okay, in langchain, LLM would reply you, you are asking about which product, right? But as the memory component is present, if I ask second question, what are the features of this product, the in the backend, my langchain will send the LLM the product ID I'm talking about, right? So this memory component is very important when we are working on chatbots mostly, right? Because otherwise, if memory components are not there, the working on chatbot or the users of chatbot would be frustrated, right? Okay, and then next agents, the last component are agents or tools. I think mostly you have heard about agentic AI, right? It is about that. Okay, now using agents or tools, we can prepare AI agents using this component. Okay, so LLM, basically we all know, we have seen in previous videos, LLM has got NLU, natural language understanding, and context aware text generation capabilities, right? So the first obvious use case of LLM is chatbots, and we are seeing there are many chatbots that are getting prepared. Okay, many chatbots use cases have got handled. Okay, now, chatbot is fine. The next thought is like, if this chatbot can do some work for us, okay? For example, let's consider we are talking to some application like Book My Show, right? I have asked chatbot like, what is the best rated movie currently available on Book My Show in my city, right? Let's say LLM gave me answer as, let's say, movie one. Okay, I'll just tell you the first question. Let's say I have asked, which is best rated movie available on Book My Show in my city, right? Maybe city name I'm giving. Let's say LLM gives me a response back saying there is movie with movie name 1 having rating 4.2. There is another movie with let's say movie 2 name having rating 4.1. Right? Okay, fine. Chatbot is working. I'm happy with that, right? Now, if I ask the chatbot, which is the, let's say, cheapest price, okay, which is the theater having cheapest price for these two movies, right? So theater having cheapest, right, price and time for above movies, right? Let's say it has given me the answer. Let's say theater 1, okay. The price is 100 and the time is, let's say, 8:30 a.m., right? You might remember your engineering days. I think, yeah, while we were in engineering, we used to attend the morning shows for movies, and those were very cheapest, right? So let's say we get some 3 4 responses like that, okay. Now in next step, if I ask chatbot to book the ticket, right? This ticket, I want to book the ticket of theater 1 having price 100 and timing is 8:30 a.m. The next thing chatbot should do is give me the available tickets, available seats, right? What are the seats available? And I should be able to book the ticket using same chatbot, right? So AI agent basically has two things which are not with chatbots. Okay. Those two things are reasoning capabilities and tools access, right? So here our LLM has got reasoning capability. Okay. And the tools access as in it has got the book my show tool access, right? Using these two capabilities, AI agents can get the work done. So to, let's say, in this example, you don't need to go to book my show to book the ticket. You don't need to search. You can do it using chatbot itself, right? Your chatbot will book the tickets for you, right? So yeah, that's the example of that is what agent or tools in LangChain, right? And this also we are going to learn totally in depth. I think next around around 3 to 4 months, max to max, we'll be learning LangChain, right? Generative AI using LangChain in details, in depth, right? Fine. I think that's all for this video. From the next video, we are going to start with the setup for coding using LangChain, right? And then we will be going to start learning about all the codings that we need to do, right? In LangChain. Everything theory that we have learned, we are going to experience that, okay? From next video, right? Fine. That's all. Thank you so much for all your response, and I'll see you in the next video.